Today we have to study of the state of a system. State of a system. I write down state of a system. State of a system. Right? State of a system that we have learned today. State of a system. Right. So we need to know what is the state of a system. That is simple thing. I'll explain. So keep work with me, right? So if we consider gas, PV is equal in so if we consider gas, so this is the equation that we use to do the calculation regarding the gases. So here when it comes to the R is a constant that is called universal constant. R is a constant value. It is called universal constant. So when it comes to the description of a gas, so here we can use a pressure, and this is called volume, and this is the number of mole, and this is the temperature. All the other factors are changing. Those are changing variables. The only factor is the R, the universal gas constant, that is a constant value. When it comes to pressure, volume, and number of moles, and the temperature, those are varies. So we can change those things. So if we get a gas sample like A, and also if we get a gas sample like B, if we get a gas sample like B, so here, so I'll consider this is my gas sample, which is A, and this one is another gas sample, right, which is called that is B. So if I put a thermometer here somehow, let's think that I'm going to measure the temperature of this one, the gas sample, I will get that one as T1. And also I measure the volume is 1, V1. And then also I know the number of moles, that is N1. That is N1. And also I'll measure the pressure, that is P1. I'll measure the pressure, that is P1. And here also I'll measure the pressure, that is P1, temperature T1, V1 and N1. T1, V1 and N1. Both are same. Both are same in this situation. Right? It means the state of A and state of B sample are same. State of A and state of B are same. So when it comes to the state, description of state in energetic relation, the state mean kind of a description of the system by using some properties. Normally, the properties, there are two types: macroscopic properties and microscopic properties. Right? So here, what we use macroscopic properties. Here we use macroscopic properties. So state of a system meaning we use macroscopic properties. I'll tell macro properties. Macro properties. We describe the system using macro property. Right? So when it comes to gases, so we can use pressure to describe the system, and we use volume to describe the system. We can use number of moles to describe the system, and we can use the temperature to describe the system. So let's get another two system. Right? So now here we measure the temperature, not the pressure. We measure the temperature, and we measure the number of volume. Let's see, now A only measure the temperature and the number of moles. And then when it comes to B, it's measure pressure, temperature, volume, and number of moles. It measure all the variables. So if we talk about these two systems, so I know the system B better than system A, and you also know about the system B than the system A. It means if they have described the system by using many macro properties, when the number of macro property that they use to describe the system increase, so we know the system very well than the system A. That is what it means. So we have friends, and we know their names, home address, and so on, many things. and we meet another new friend and we don't know much about him, it means, so when it comes to our states, right? It is something like that, that we know a person better than another person, right? So we can describe the things regarding our friends than an unknown person. So we know the system very well and we don't know the system very well. When it comes to the atoms, molecules, ions, and so like things. So if we are going to describe the state of that system, so we need to use their properties. Their properties. My friend, he is a very good person and he is white color. Likewise, things. When it comes to the lesson, we use to describe the state, we use the name state, and we use properties, what are macro properties to describe the state. We use pressure, volume, number of moles, temperature. Likewise, there are many properties that we can use to describe the state of a system. So state of the system means, so we know the values of the system at which it stay, at which it stay. We know the value of the pressure, mean we know some state of the system. We know the state of the pressure of the system. If we know the temperature of the system, it means we know the state of the temperature of the system. If we know the number of moles of the system, it means we know the state of the number of moles of the system. Right? That is it. So to describe the state, we use the functions which are called pressure, volume, number of moles, and temperature. So these about the gases. When it comes to liquid, liquid diagram. When it comes to liquid, right? Here I have a liquid which is called A, and here another liquid which is called B. So if we put a thermometer here and there is temperature, let's call it T naught, and here they do not going to measure the temperature, and we know the volume, that is V naught, and here volume is V1. So likewise, and we know the pressure, that is atmospheric pressure when it is open, and here also the pressure is atmospheric pressure when it is open. When something is open, the pressure is equal to the atmospheric pressure. So here, so we know the temperature, pressure, and the volume. And here only we know pressure and the volume of the system. It means only we know two state, pressure and the volume. When it comes to A, we know three state of the system. Volume we know, temperature we know, pressure we know. It means we know system A than system B. We know system A, the state of the system A, than system B. That is what it calls. So when it comes to the gases and liquids and all the things, we can use pressure, volume, number of moles, and temperature. Again, when it comes to the number of moles, so we know the equation, number of moles is equal the mass over molecular mass. Number of moles is equal mass over molecular mass. If in these two or in these two, if we use same gas or same liquid, the number of the molecular mass is constant. Therefore, when the molecular mass is constant, number of moles is proportional to the mass. Therefore, we can use here either number of moles or number of moles or the mass. Number of moles or the mass also we can use. So that is it about that part. About that part. Right? State of the system. So now I hope that you get kind of idea about state of a system. State of a system means we use some certain macro properties to describe the system like pressure, volume, number of moles, temperature, mass, like properties. By using those values, we can describe the state of a system. So that is it. So that is it. And then let's move to the next part of the period. So I'll move to the next part of the period. So when it comes to state, when it comes to state, the system can have some different points of the state. Different point of the state. So if we use a beaker, so now what normally we do practicals in laboratory, we use a beaker and we put some chemicals, into that one. We put some chemicals and then we do a practical. So here this one the inner side of our system. This is the system, right? So this is our system. This is our system, and this is our what? This is our surrounding. This is our surrounding, and this is our system, right? This is our system, and this is the boundary, and this is surrounding. All the other things are surrounding. So when system, right? When system at the state where it do not start to interact with the surrounding, right? When the system at the state where it do not start to interact with the surrounding. Now here, if the system isn't start to interact with the surrounding, we call that point as we call that point as start. We call that point as start, right? Or we say initial state. So let's use this word, initial state. So what is initial state? Initial state is the state where system do not start to interact with the system. Right? So I have given certain things, initial and final state. The initial state, how the system was before any changes or interactions with the surrounding. Before any changes or interact with the surrounding. And then initial state, and then there can be final state, and then final state. Initial state and the final state. So when it comes to a final state, the final state is a state after the system interact with the surrounding, right? After the interactions with the surrounding. So we call that state as the final state. We call that state as the final state. The final state is how the system is after interacting with surrounding. Initial state, the state, how the state before the interacting with its surrounding. Final state, how the state after the interacting with its surrounding. So those are the two states. And then there can be intermediate states also. There can be some intermediate state. If you need, you can write down. So these are system. And these some kind of intermediate interactions. There can be many intermediate states. Other than the final and the initial and the final state. So there can be many intermediate states. So what are the intermediate states? The states where the system keep interacting with the surrounding. Where the system keep interacting with the surrounding is called intermediate system. And the state of the system is intermediate state. Intermediate state of the system. Intermediate state of the system means the system keep interacting with the surrounding. That is called intermediate state of the system. So there can be many intermediate systems. Right? Keep acting full. And then so I will move to the next round. So what you can do is, now there's a box in the PDF. So you can write down within that box, you can write down something like this, right? Initial and the final state. So what we can do is we can write down initial state. and the final state. Initial state and the final state. And also you can draw something which is called initial state, final state, and also you can draw intermediate state. Intermediate state. If you need, you can draw that one. So you can draw these three things within in the box in the PDF. So that is it. And then initial state and the final state. So let's move to the next one, page number 7, state variables. State variables. Next part, page number 7, state variables. State variables. Write down topic, state variables. Right? We can write down state variables. එහෙම නැත්නම් මේකේ ගොඩක් වෙලාවට පාවිච්චි වෙනවා අපි state functions. State functions. So this is the word that we use mostly. State variables or state functions. State function. Use state function. The word called state function. Use that one. State function. So we use these state variables to describe system. To describe a system. The variables we use to describe a system called state variables. The variables used to describe the system called state variables. And also we use a word here, functions, state functions. The students who are doing maths, they familiar with the name called functions. And also in biology students, there is some part they use the name functions when it comes to the calculation regarding the plant, something I don't remember much now. But they also use not much than the math students. However, in this unit we have to use the name which is called functions. There is also variables. Here we call the variables and also functions. We use the name function. So that is it about that one. So what are the state variables that normally we use? So we can remember this one. PV is equal to nRT equation. PV is equal to nRT. So pressure is one state function. Volume is also another state function. The number of moles is also state function, and also instead of that one we use mass. The mass is also state function. This is a constant, and this one temperature is also state function. Temperature is also state function. So that is it about that one, right? And also there is another little description that we need to know about state function. The small thing that we need to know about this state function is, right? Now here we come to the topic. Now here we come to the topic. So take 2 to 3 seconds and empty your mind. So then work with me. 1, 2, 3. Okay, let's start this one. State functions. Now you know the certain few state functions, the things that we use to describe the system, and there is very important thing regarding state functions that we need to know. Right? Important thing is state functions depend only on. So the state functions depend only on the initial state, and the final state of the system. Initial state and the final. Initial state and the final state of the system. State functions depend only on initial state and the final state of the system. Initial state and the final state of the system, that is much more important. It means it do not depend on the intermediate steps. So if you need, you can write down. The state functions do not depend on the intermediate steps. No matter how many intermediate steps are there. How many intermediate steps are there? State functions only depend on the initial state and the final state. Initial state and the final state. Now, in the PDF, in your PDF, there is a books. So now we are going to fill that one. So we are going to fill that one. We are going to fill that one. Right? So I will give, so what we can do is we can draw that one, the things in that box. So here I will give a 3D curve. So one, right, let's consider three experiments here. Three experiments. Let's consider three experiments. Here this one. And here I'll get the final state. I'll get the final state. So here these are initial, right? Initial state. And this one is final. Final state. Initial state and the final state. Here what we are going to do. So we are going to do, what we are going to do is we are going to measure the temperature. So here let's think the temperature is 25 Celsius. And here the final state, the temperature is equal 100 Celsius. Now this is the experiment that person A conduct. A guy conduct this one, the initial state and the final state. Initial state temperature was 25, the final state temperature is 100. And then there's another guy, he's also doing experiment. Now he's also measure the temperature. Now here there's another state which is called intermediate state. And he also get the temperature at the end, the final state. Final state. Now this is the person B. Right? Person B. Person B now. This is the guy B. He's also doing experiment, and here he measured the temperature that is also 25 Celsius. And there was intermediate temperature that is, let's call that is as 50 Celsius. And the final temperature that is 100 Celsius. Final temperature is 100 Celsius. That is it. Right? That is it. And then another person who is C, and she is a girl. What she is doing, right now, she's trying to do better. In that case, she will have two intermediate states, and then finally she also come to the final state, and she also measure the temperature. Here T, that is 25 Celsius, and here also temperature T, that is like thing that is also some kind of 40 Celsius, and then here she measured the temperature. So let's think that is 80 Celsius, and then she measured the temperature here, that is also 100 Celsius. So these are three experiments. Now what is our state function? State function is temperature. All these three students, they measure the temperature as their state function. Now what they are going to do is they are going to check whether the state function, which is temperature, depend on the intermediate state, or they are going to check that the statement which is called that the state functions depend only the initial state and the final state. Now they are going to check that one. Right? So normally when we get the value for the state functions, right? So we get something like this one, right? Initial temperature and the final temperature, we get the temperature different, right? Right? So I'll call that one as delta T, which is called temperature different. So T final minus T initial. T, yeah, you can see it. Delta T is equal T final minus T initial. That is how we get the temperature difference. Right? So the temperature difference of A guy temperature difference of A, that is equal 100 minus 25, 100 minus 25, that is 75 Celsius. And let's move to B. Delta T of B, that is equal 100 Celsius minus 25 Celsius, that is 75 Celsius. And also let's move to B. B, yeah, that is okay. Now let's move to the C. Delta T, C, temperature difference of the C. 100 Celsius minus 25 Celsius. And that is also 75 Celsius. That is also 75 Celsius. Now what we can say is temperature difference, right? So I'll tell delta TA, that is equal delta TB, that is equal delta TC, delta TC. It means no matter the number of initial states, the temperature difference or the state function temperature, it depends only the final state and the initial state. Final state and the initial state. Final state and the initial state. In that case, we can write down equation. So now here we can create an equation for this one. Right? So what we can do is we can create an equation for this one. Right? State function. Right? State function. The difference of state function delta SF, I'll call that one, right? State function, the difference of the state function. The value of the state function we get, right? We get so value of state function, right? Value of state function. Value of state function. How we can get the value of state function? So we can get the value of the initial state, value of the initial state, value of the final, right? Here, how we get value of the final state, value of the final state minus value of the initial state, value of the initial state. The value of the state function, so it's called delta value, the difference, delta value of the state function. So how we can get it? Value of the initial final state minus the value of the initial state. Value of the final state minus value of the initial state. So this is the equation, the final thing. So what you need to write down within that box is these things. Initial state, final state. So we have A, B and C, A, B and C. And then we get the delta T difference of A, delta T difference of B and C. So we can observe that delta TA is equal delta TB, that is equal delta TC. So by using that one, we get an equation for the delta value of the state function. The delta value of the state function, that is equal the value of the final state minus the value of the initial state. So because of the equation, this one, the definition of the state function, so these do not depend on the intermediate steps. Do not depend on the intermediate steps. Right, that is it for the page number 7. And then let's move to page number 8. Let's move to page number 8. Okay. Let's move to page number 8. I will remove this part. And then we move to the page number 8. Right. So in page number 8, so we are going to get more understanding about the state function. We are going to get more understanding about the state functions. So normally, if you even we do not know the temperature is state function, but we have used that one. When we do calculation in O level, we use temperature difference and all the things, but the thing is we didn't use the word which is called state functions. We didn't use that one. What is it? It's almost 1 hour, right? We do not use the word which is called state functions. But when it comes to energy, we use the word is called state function, and temperature is also state function. Now let's move to page number 8. Understanding state functions. So I'll help you to understand more about state function, because in this lesson, so we work with the state functions. In that case, we have to know about more. We have to know more about the state function. That is it. So I am going to help with that part. State function. Now, hope you all have. No, some of you may have what's the anime which is called the Naruto? That is TV series, anime TV series. And I have put their names, right? Sasuke, Sakura, and Naruto. Now here, there's three graphs. Three graphs here. Three graphs. So understanding state functions. Right. Okay. So you can write down understanding state functions. You can write down MGH, potential energy. MGH, potential energy. Right. Potential energy is also a state function. Write down. Potential energy is also a state function. MGH. Potential energy is also a state function. In this lesson, right? In this lesson, what we do, we learn about the variation of the mainly potential energy of the atoms, molecules, and the ions. So, but we do not use about the potential energy when it comes to the energetics, the working with the molecule level. But when we work with the high masses like humans and all the things that we can work in the day-to-day life, we use the word the potential energy and the MGH. We have worked with that one, and we have done the calculation in volume. So therefore, you know about the MGH more, which is a state function. So let's get that one to understand state functions which we have learned in energies. So MGH, the potential energy is also a state function. You can write it down. Potential energy is also a state function. And then, so let's move to the example that I have given in the PDF. Here, so what you can do is you can write down here MGH. Right? Here you can write down MGH, and also there is another one that is also MGH, and there is another one MGH. Now here in the first one, the first image, right? In the first one, so here there is a line, and here there is a line, and here also there is a line. Right. Okay. And also in the here same level. Now let's get the MGH here. MGH is equal 0. MGH is equal 0. MGH is equal 0. So I will put the name of their names. In here there is Sasuke is there. Right? Sasuke, and here Sakura. She is a girl. And here the Naruto. Right? Sasuke, Sakura, and Naruto. Now we are going to now let's think that they climb something. They climb on something, and here Sasuke is here, right? Sasuke is here, and also Sakura is also here, and the guy Naruto, he is also here, right? Now Sasuke used only one step to climb here. There's only one step, and he goes there. Right? So here let's get MGH, that is equal 100, and here MGH, that is equal 100. MGH is equal 100. Right? Here the Sakura, she used 2 steps to climb there. 2 steps to climb there. Here. And also finally she comes to the final step. She climbs here and she climbs here. two step, right? Here we call step 1, and here step 1, step 2, step 2, 2 step. Naruto, he takes three steps. He finally initially go here, right? Initially go here, and then here, and finally he goes the final step. 3 steps is there. Now comes here the final guy, 1, 2, and here finally the final step, right? Oh, right. Step 1, step 2, step 3. Step 1, step 2 is step 3, right? Now let's put the value of the potential energies in each steps. So here 0, and here GH, that is equal 50, and here MGH, that is equal like 40, and MGH, that is equal 80, likewise. The first person use 1 step, the second person take 2 steps, the third person take 3 steps to climb the position where MGH is equal to 100, right? Now MGH, the potential energy, is also a state function. We know how to calculate the delta value of the state function. It means the difference of the state function, right? So we get the value mgh delta E value of Sasuke, that is equal the final minus initial, 100 minus 0, 100 minus 0, that is 100, right? Let's get kilojoule, 100 kilojoule, right? Sakura, delta E Sakura, that is equal 100 minus 0, 100 kilojoule. Delta E Naruto, that is equal 100 minus 0, 100 kilojoule, 100 kilojoule. So can I do the calculation? So you can do the calculation, these things, and then I'll come to the final one. Potential energy of Sasuke, different boxes there, right? So what you can do, Sasuke is equal Sasuke, you can do the calculation over there. And then so let's move to page number 9, the potential energy of Sakura. So you can do the calculations over there. Potential energy of the Naruto. So you can do the calculations over there. And there is potential energy as a state function. Potential energy as a state function. And there is another box. Now I am going to move to that one. Potential energy as a state function. Potential energy as a state function. Potential energy as a state function. What we can write down with that box? Delta E is equal, delta E, right? Delta E Sasuke is equal, delta E Sasuke is equal, right? So you better write this one, and then I'll use space here. Delta E is equal, delta E Sasuke, that is equal, delta E Sakura, that is equal, delta E Naruto, right? So this is the thing that you can write down in the final box. The potential energy, it depends only the initial state and the final state, not the intermediate states. Potential energy, right? So the potential energy of the Sakura at the end, that is 100 kilojoule. Potential energy of the Sasuke at the end, that is 100 kilojoule, as well as the potential energy of the Naruto at the end, that is 100. No matter the Sasuke use 1 step, no matter Sakura use 2 steps, the final thing is 100 since the initial one is 0. No matter the Naruto take 3 steps to climb that gap, the value is 100 kilojoule, right? no matter the number of steps. When it comes to state functions, what we really matter is not the intermediate step, but the final state and the initial state. So it means very well we need to know the value of the initial state and the value of the final state. Value of the initial state and the value of final state. If you know those two, we do not need to consider what has happened in the middle. So we can do the calculations just by getting the difference between the final state and the initial state. So we do not need to know all the other intermediate steps. That is the benefit of the state functions. The benefit of the state functions. So we can do the calculations if we know only the value of the final state and the initial state. So that is it. Then let's move to the page number 10. Page number 10. So can I write down this one? And then let's move to page number 10. So I'll send you the recording. So if you don't have time to write these things, you can watch the video later while writing the note. Right. Now what you can do is you can take a paper and then try to write something when I teach and when I write. So you can work with me. Otherwise, it will not work well, right? So, however, I'll do my job. So it's your thing to you do your job, right? So I'll do my job. So main state functions in this lesson. Now we move to the another part, right? 10, 11, and 12. There's only 3 pages. So now, yeah, almost 1 hour has taken. So it will not take much time. Now, main state functions in this lesson. Main state functions. Main state functions. Functions in this lesson. 3 main state functions in this lesson. 3. Right? The one is enthalpy. Enthalpy. We use H. Enthalpy. We use H. Enthalpy. Enthalpy. We use H. And then we get enthalpy difference. Enthalpy difference. Right? Enthalpy difference. If we get the enthalpy difference, it means, right? So I write down something we call enthalpy change. That is called enthalpy change. That is, we denote as delta H. So you can write down this one, right? I haven't given that one in the note. Enthalpy is H. Enthalpy change is delta H. Enthalpy change is delta H. This is the first thing that we have learned. So I have given some descriptions over there, but I will describe that when the place we have learned about the enthalpy. So up to now, enthalpy is state function, and enthalpy change is delta H. Enthalpy denote H. Enthalpy change denote delta H. And the second state function, second state function, I have given entropy. Entropy. I have given entropy. This is, we use S. Entropy change. Entropy change. Entropy change. We use delta S. And the third one, entropy change, and third one, we use Gibbs free energy. Gives free energy. And change. Right? Gives energy change. Use delta G. Gives energy change, delta G. What are things? Enthalpy, entropy, gives free energy. Those are 3 things. 3 factors. So what are those 3 factors? Enthalpy, entropy, gives free energy. These are 3 state functions. 3 main state functions we learn in this unit. Enthalpy, entropy gives free energy or gives energy. Enthalpy, entropy gives free energy. So when we do calculations regarding enthalpy, whatever it is, or regarding entropy, whatever it is, and regarding gives free energy, whatever it is. So you can keep in mind those are the calculations we can done similar to the potential energy MGH, because these also state functions, not big things, right? Bioelectron, enthalpy, entropy, MGH, similar things, give free energy, entropy, likewise things. And then since we have three state functions, main state functions, there's equation delta G is equal delta H, delta means change, delta H minus T delta S, and there's the equations to combine these three state functions. Delta G is equal delta H minus T delta S. So that is the equation which combine these three state functions. So we have to learn about enthalpy and also entropy and also Gibbs free energy and also about this equation, right? In the coming lessons. So let's move to the next one. Now it is these are the three state functions. But what are those? Enthalpy, entropy, and gives free energy. Gives free energy. Right, that is it. And then we will move to the next part. Standard state. Standard state. Standard state. Right. The next one is standard state. Standard state. So we have to work with the standard state. To identify standard state is something like this. Right? So let's think we do kind of experiment and you measure temperature and get some kind of energy change here, like 100, right? T2 minus T1, you get delta T. And then your friend is doing the same thing, right? He get delta T value, T3 something like 3, 4, and the T value was 120 kilojoule. Now you are going to publish these values somewhere to the world. So we are going to tell that I have done a certain experiment. In that experiment, the value is 100. So then your friend is saying, no, that is not the actual value, that is 120. I'm going to publish it. So a standard state defined to remove this kind of mistakes, happening this kind of mistakes. So in that case, what we do is we give the fixed values for the state functions. We give fixed values to the certain state functions. Right. So what was the functions PV is equal nRT. So when it comes to pressure, they give the standard value is 1 atm. 1 atm. That is the standard value, 1 atm. When it comes to temperature, 298 Kelvin or 25 Celsius, that is a standard one. Right? That is standard one. Now pressure is okay, temperature is okay, right? When it comes to the number of moles, normally we get 1 moles, and when it comes to the volume, we get 1 cubic decimeter. So normally by using these two, we get the concentration, right? We use the moles per cubic decimeter. 1 moles per cubic decimeter solutions that we use when it comes to the solutions. When it comes to gases, we use pressure 1 atm, use temperature 298 Kelvin and 25 Celsius. The number of moles 1, volume is 1 cubic decimeter, and combine those two, we give concentration value 1 moles per cubic decimeter. So these are the standard values. Now, if we are going to publish those the values in those experiment, so you also need to do the standard way and So we can say that the value, this is the energy value that we have obtained when the experiment carried out the standard pressure temperature conditions. And the other person also can tell that, so this is the value that I have obtained by conducting the experiment at the standard conditions. It means the all knows that what are the temperature, pressure and the other conditions that the experiment conduct. So in that case, the errors will not occur all around the world. So that is why we use standard conditions. Now you know standard states. What are the standard states? So that is in the page number 11 things, right? Now, so when it comes to standard states, right? Enthalpy, standard enthalpy you put here no delta H standard enthalpy, right? So this one is standard enthalpy. Enthalpy. Standard enthalpy means the H no standard enthalpy change. Standard enthalpy change. Delta H theta naught. Delta H theta naught. Standard enthalpy change. Same thing we can write for the entropy and the Gibbs free energy. Entropy and the Gibbs free energy. Standard enthalpy. So let's write down standard entropy. Standard entropy. Standard entropy is not standard entropy change. Standard entropy change. Delta S naught. So this is how we denote. And then standard Gibbs energy. G naught. Standard, right? Standard Gibbs energy change. Delta G naught. Right? Those are the things. But standard enthalpy H naught. Standard enthalpy change delta H theta naught. Standard entropy S naught. Standard entropy change delta S naught. Standard Gibbs energy G naught. Standard Gibbs energy change delta G naught. So these are important, right? The one last time. Standard enthalpy H naught. Standard enthalpy change delta H naught. Standard entropy S naught. Standard entropy change delta H naught. Standard Gibbs energy G naught. Standard Gibbs energy change delta G naught. And if you do not use correct abbreviations, you will not get marks. If you write down delta G naught where it says just Gibbs energy, so they will not give mark unless, so we can use delta G naught when it says the conditions system at the standard state, we use naught. If the temperature and pressure values are not matched with the standard conditions, we cannot use this naught there. So either you can write down naught or you can write down naught and cross that. So here I'll just write down naught. So that is it. So that is that part. And then there's more two things. Now body carbon thing or material right? Take let's take 5 seconds and move to the next one. Right? 1, 2, 3, 4, yeah, 5. Now let's move to the other one. Reversible and irreversible reactions. Reversible and irreversible reactions. So when we do experiments, we need to know the reaction is reversible or reaction is irreversible. So I'll explain the reversibility and the irreversibility of the reactions, right? Initially, I'll get this one, right? Irreversible reactions. Irreversible reactions. So when it comes to irreversible reactions, those are the reactions that we have worked up to now, starting from the O level to up to now. So we have worked with the irreversible reactions. It means when there's reactants, and they will convert to products. Reactants, they will convert to products. Right? So what is the reaction? Reaction means the reactant converts to something else which is called products. And those kind of things are reactions. So when irreversible reactions, when we consider, the reactant will convert to product. There is only one way reaction. So we cannot use product to form reactants, and yeah, we can do that one, but it requires much energy. That is something else. Therefore, normally we say that irreversible reactions, the when we start from the reactants, it will give product, but it is much more difficult to get the reactant by starting from that product. It means we say, therefore we say, irreversible reactions are the reactions only one-way reactions. We can start from the reactant and we can form the product. So what are the properties of the irreversible reactions? Right? Initially there can be only reactant in the reaction mixture. At the end there can be only product in the reaction mixture. Unless if we use more reactant, like in we combust, we normally we normally heat with excess oxygen. In that case, there will be some the remaining oxygen in the reaction mixture. Unless that, right? If we react a reactant in stoichiometric ratios, in that case, there will be no reactant at the end. There will be only product at the end. Initially, there will be reactant. At the end, there will be only product. One-way reactions, only reactant or product present in the reaction mixture. Likewise, some properties are there. So you know these things. So then I'll move to the next type of reaction. That is called reversible reaction. Reversible reaction. Reversible reaction. So those are reversible reactions. Right? Irreversible reactions. Now these are reversible reactions. We can start from the reactant. Reactants. We start from the reactant and we go to the product. And also we can start from the product to form reactant. I'll demonstrate that one. Right? So here you can, hope you can see some kind of orange color. Orange color thing is there. So this is K2Cr2O7. 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 So I'll get a little bit of K2Cr2O7 to a beaker, right? A little bit of, right? Now you can see that is orange color, and I'll use a small amount of H2O, to dissolve this one. I'll put, yeah. Now you can observe the color. Now I'll use some mechanical force to that one to dissolve until it dissolve, right? A little bit more there. So you can see that is orange in color, orange color. Now here's some K2Cr2O7, the color is orange. If you need, you can write down. This is one of the practical that we are doing. Unit 12 under chemical equilibrium. Chemical equilibrium is orange. Is orange color. Is orange color. Is orange color. Now this all orange color. Here I have. You can hear the sound. So this is these are sodium hydroxide pellets. Those are pellets, sodium hydroxide pellets. I'll put some sodium hydroxide into distilled water, and then I'll dissolve certain NaOH sodium hydroxide pellets. So here we dissolve sodium hydroxide pellets. So you can observe the sodium hydroxide. Right? You can observe the something is going there, dissolve, slowly dissolve. So until it dissolve, right? I'll get concentrated here. Concentrated HCl is there, so you can see the mist is going. Right? You can see that one. Since that is concentrated HCl, I'll so I'll get concentrated HCl into this one. So So this one is distilled water, I see. So I add some HCl into that one and I'm going to close this one. Now here this one has NaOH what we dissolve and this orange color. Now I will put NaOH into this one. Now I have this one K2Cr2O7 that is orange color. Here we have NaOH. So we mix some NaOH into that one. So we can observe the color change, right? Color has changed now. Color has changed. Color changed to yellow. Color changed to yellow. It means something something else form. Something else form. CrO4 2 minus is yellow color. CrO4 2 minus. We can say K2Cr2O7. Let's say it's only ions. Cr2O7 2 minus. This is orange. And converts to CrO4 2 minus. CrO4 2 minus, which is yellow. What we put here? We put here NaOH and I will say OH minus. Right? When we add base, when we add a base, when you add base, it changes color. So you can compare the color. Initially, the color was this one, and the final color was this one when we add NaOH. Right? That is the color change. And then, right, and then, okay. Now here we have this one. After that, what we can do is, right, what we can do. Now we get some reactant. We get some reactant gata, and then we get a product, which is yellow color. And now what I am going to do is, I'll get that HCl which we dissolve, and I will put HCl into this one. HCl into this one. Now you can observe the color change. Now it turns the previous color orange. Previous color orange. Orange. It turns in color. It means, so we start with the product which is yellow and it turns to orange again. So here, what we put here, we put HCl over there. It means H plus ions. Now this is called equilibrium. So under chemical equilibrium, this is one of the practical that we have learned. One of the practical that we have learned. Right? So reversible reactions, we can start from the product to get, we can start from the reactant to get product. Either we can start from the product to get reactant. Right? Always there will be reactant and the product at the reaction mixture. Always there will be reactant and the product in the reaction mixture. Always. So what will happen if we add again NaOH to this one, right? Now we have orange here, this one, and here OH minus is there. Now I'm going to add the remaining OH minus, right? Now here we have here is orange color, right? This orange color, let's add NaOH. OH minus, that converts to yellow, right? That converts to yellow. It means it goes here. It goes here. it goes here. Now this is H plus, right? This is H plus. Now let's add H plus into here, right? Now this is H plus. Now we add H plus into yellow color. Cr over 2 minus. Now it goes here, it goes down. We add it here, so you can see both are present. Both are present, right? You can observe, right? Both are present. Now it gradually goes down. Gradually goes down. Finally, we have this Cr2 ozone 2 minus. Those are the reversible reactions. It means, so that is it. It means the reactions, the reversible reactions, either we can start from the reactant to get the product, either we can start from the product to get the reactant. What are the properties? Always there will be both reactant and the product present in the reaction mixture. The reaction is vice versa. It means it can take both directions. Take both directions. So that is it. So what you can, in the page number 11, there is a box. So what you can do is, you can write down these things within that box. Page number 11, you can write these things. In the irreversible process, right? Page number 11, there is irreversible process. Irreversible, and within that box, you can write down carbon plus oxygen. You will give carbon dioxide and H2O. This is irreversible reaction, right? Irreversible reaction. So normally when we keep carbon outside, it will not form carbon dioxide. So we have to give some energy. We have to give some energy to take that. Right? So you can write down some example. Irreversible reactions is something like. And page number 12, there's the box. Reversible reactions. Within that box, you can write down this one, page number 12. Right. That's it. The last one. Last one. Let's see the time. Yeah, 5:28. 10 minutes. Pinadi the high in there. 10 minutes more. 10 minutes more. I'll remove this one. And then the last one is the spontaneous reactions and non-spontaneous reactions. The last topic. Right? So if we work in the PDF, it says what it says. Initially states, yeah, spontaneous reactions. Right? Spontaneous reactions. Spontaneous reactions. The other one is non-spontaneous reactions. This one is also reactions, right? The final topic in today's lesson. අවසාන topic එකක් බලමු. Spontaneous reactions and non-spontaneous reactions. Spontaneous reactions are the reactions which occurs naturally. Right? Another one. The spontaneous reactions are the reactions which do not require any energy to occur. Right? The reactions which do not require to any energy to occur. So here we describe about the reactions at normal conditions that we are living, right? In the room temperature and pressure conditions, it means standard conditions. Let's say standard condition. If the reaction occurs without giving any energy, right? At the standard condition, normal conditions, we call spontaneous reactions. Normally, the reactions occurs in biological systems, right? Those are spontaneous reactions. Most of the reactions occurs in biological systems. Reactions those are spontaneous reactions, biological reactions, spontaneous reactions. Ice melting, right? So if we keep some ice in room temperature, it will melt. Spontaneous reactions, ice melt. Those are spontaneous reactions. We do not need to give some energy to occur the reaction. It will happen naturally. It will happen automatically. It will happen. Right? So what are the spontaneous reactions? The reactions do not require any energy to occur at normal conditions. Those are spontaneous reactions. Melting of ice at room temperature, normal conditions. biological reactions occurs in human body, most of the biological reactions. So that is it. We know about that. Spontaneous reactions automatically occurs. Non-spontaneous reactions. Non-spontaneous reactions may need some energy to occur. Like carbon, if we give carbon in oxygen, they do not react to form carbon dioxide unless we heat, unless we give some energy. Non-spontaneous reactions may need some energy to occur, but spontaneous reactions do not need energy to occur. They will occur spontaneously. That is why we call spontaneously, automatically occurs those reactions. To occur non-spontaneous reactions, we need to supply some energy, right, to occur that reactions, like these kind of reactions. So you can something you can write anything that you need. So that is it for today's session.